Hi, this is Glenn Burden with the Maker Hive, and today I want to introduce you to the eSwitch kit from Yellow Jacket Concepts. The eSwitch is a convenient and easy way to control a heavy load using a microcontroller or a low current switch. The eSwitch has inputs for a low level and a high level trigger, marked with the L and the H respectively. It has a ground output and a ground input. The eSwitch kit comes with everything you need to assemble your eSwitch in either configuration for high level or low level trigger. In each kit you'll get a MOSFET and a transistor. You'll also receive two 10K ohm resistors and a 680 resistor. You'll receive male and female headers depending on how you want to configure it. You can use it with jumper wires with the female headers, or you could put the male headers in and plug it into a breadboard. There's several different ways you can configure it. You can even solder your wires directly to it if you want. You also get the board itself, and you'll get a 1 amp diode that will be used for the flyback. And it's important on installing this, and there's a couple different ways to install it. I suggest you watch the rest of this video and check the PDF before soldering this onto the board. The downloadable PDF file shows several different ways and examples of how to use the eSwitch. Each one will show you what components you need to install on the board depending on if you want a high level or a low level trigger. In this configuration, it's being used as a high level trigger from a Arduino coming in on the high input. I have 12 volt source connected to the positive on the board, which is in this case used as a pass-through, and Q1, the transistor, is not installed. The load is a 12 volt motor, and it's important to have the flyback diode installed, and since I'm using the 12 volt running it through the board, I can install the diode on the board. But if I can't or don't want to run the power for the pump through this board, you can install the flyback diode across the load. Here's an example of using the same configuration running the same motor using a low level trigger from the Arduino on the low input. In this case we do need to install Q1 transistor, and the voltage max to power the transistor is 5 volts. So we can't run our 12 volt pass-through voltage there for the pump. We have to get it from another source. In this case we do not want to install diode D1 on the board, as it'll allow a 7 volt backfeed. In this case we want to install the diode directly across the load in reverse bias configuration. By now you're probably wondering what this little tab here off to the side is for. So it can also be used in conjunction with the Yellow Jacket pick and distribution block, or the YJ pad. It's designed to plug right into the pad here on these outside outboard headers, just like that. And now you have a spring cage wire connection, no butt connecting, no soldering, and it also allows easy replacement if something was to happen to it. You can see that the eSwitch has 5 inputs across the bottom and the same inputs across the top. You have a ground, your ground out, your high trigger in, your low trigger in, and positive. And those would directly correlate with the 5 input pins on the YJ pad. So 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Your number 1 is ground, number 2 is your output, number 3 is your high level trigger, number 4 is your low level trigger, and number 5 is your positive. The eSwitch works great for running all kinds of heavy loads, and it's great for running the bird air cooling pump directly from your 3D printer control board. And most 3D printer control boards have a low level PWM output. You can tie right to the low level here, follow the instructions for your low level trigger, and you can control the speed of your bird air pump without worry of blowing the MOSFET on your printer controller. If your print controller happens to have a high level PWM output, you can use that as well. Follow the instructions with the high level trigger. If you do require a heavy load greater than an amp or two and the MOSFET gets really warm, there is room to install a heat sink such as this one onto the top of the MOSFET. The only thing then you want to be concerned with is maybe bend these resistors down a little bit so they're not touching the metal of the heat sink. The resistors stand up on their end like that, and the resistor part lead goes into where the circles are at. And the trick to bending these right is to use a little pair of tweezers or maybe a small pair of needle nose pliers. Just grab the resistor right there and bend it around. Gives you a nice clean bend, and it's not too close to the end of the resistor where it's going to break the lead off the resistor. So just do that to all three of them. Now the first thing you got to do is determine how you're going to use the eSwitch. If it's a low level trigger, you'll need all three resistors. If it's a high level trigger, you really don't need the second 10K because you won't be replacing the transistor Q1 on the board. But in either case, you want to start with the MOSFET first. The double line on the board corresponds to the MOSFET as if you're looking down at it. And we'll solder that in place. And then next we want to solder in the resistors. I'm going to go ahead and solder all three of them on here. It's R1 is the 10K, 2 is the 680, and 3 is a 10K as well. Okay, then next would be the transistor, the flat side towards the MOSFET, and again the diode would depend on how you're using it. If it's a high level trigger and you're running your power for the load through this board, then put it on there. Otherwise it has to go across the load in reverse bias. And reverse bias means the stripe would be towards the positive side and the send towards the negative. It's reversed to normally how a diode is installed. That allows the electromotive force, when the pump shuts off, the coil drains its energy back through the circuitry, so the diode here will short circuit it so it doesn't go back and damage the MOSFET. Now to install the pin headers, again you can install them, the females, the males, depending on how you want to use it. Plug it into a breadboard, or you can install them upside down, you can install them this way, doesn't matter. Okay, when you go to install the headers, you'll notice that there's not a hole for the 5th pin of the header. Simply pull that pin out with a pair of needle nose, just like that, and then it'll go right into place. Same with the male headers. You can pull the pin out with a pair of pliers. Now if you're not using this tab, not using it in conjunction with the YJ pad, you don't have to solder this on, obviously, and you can just cut it off there if you want to make it a little bit smaller. Maybe you got to fit it into a small space, and a pair of side cutters should do that. And that's the Yellow Jacket eSwitch. It's Glenn Burden at the Maker Hive, reminding you to be creative, be inspired, and be a maker. Stay tuned for an upcoming video on how to build your own customizable B-Box storage system.